Oops. All right, so factoring trinomials. So again, basically the same thing as factoring by grouping, except we're just doing extra steps. Normally when we do factoring a trinomial, we're going to be given something in essentially our quadratic form, our standard quadratic form. So I have ax squared plus bx plus c. Now, in this format, a, b, and c represent actual numerical values. The x's are where there's going to be variables. I'm starting off by just showing you the general steps as to what we're going to do, and then we'll use that on a couple different problems. So this first time through, it probably isn't going to make a lot of sense. Hopefully, once we add some numbers in and you go back and look at the steps, it'll make a lot more sense. So on here, first thing we're going to do is we're going to find factors. So find factors of the product of A and C, whose sum is B. Okay, thank you. So now, that sounds really confusing, right? But what we're essentially doing is we're going to take those A and C values, so the A and C value that we have over here, we're going to multiply them together. It's going to give us the product of those two, which I'm going to represent as D for right now. All right. And then we're going to take that product that we get and we're going to factor it. So we'll end up with two factors. I'm going to call them E and F for right now. Which, once you get those two factors, when you add them together, it'll give you B. That's what we have to look for in order to split the middle term. Because what we're doing is we're finding these factors, and then we're going to use these factors to split the middle value. So that's our first step. All right, going through that process. The second step is to actually split the middle term. So split the middle term, which is our B value. Yep. Into two like terms with the factors so again we're using E and F for those factors as the coefficients and once you do that, so then it'll be the same as what we did yesterday. And we'll do our factoring by grouping. But let's take a look at what our equation is going to look like now. So the equation, the first letter and the third part, these two terms, those are going to be exactly the same. So we still have our A x squared. We still have the plus C on the end. It's the middle part that's going to be different. We're going to have two terms now in the middle instead of only one. So we're going to have plus E with our x value and plus F with our x value. So instead of having B, we now have two separate terms in the middle. Once we have this, we have four terms. So once we have four terms, we can do factoring by grouping. So factor by grouping. And it's going to be the same from that point on as what we did previously. So, this is our process. And again, like I said before, the whole reason why we're doing this is to undo our multiplication. A couple weeks ago when we talked about multiplying polynomials, if you had two binomials that would be multiplied, when you multiply them together, you end up with 4 terms. Then usually those middle two terms end up combining because they're like terms, and you only have 3 terms for your final value. This is the opposite of that. So we're taking that middle term, separating it into 2 terms. Now we have 4 terms, and now we can factor using our factoring by grouping. So we're going to take a look at an example. So the example here is going to be x squared minus 2x minus 80. So now, first thing we have to do is identify what is our a and c values. Because that's the first thing that we have to do. Right? So our a value here is what? Well, the a value usually goes in front of it, right? So the actual a value is 1. So sometimes we're going to have a lead coefficient of 1. And when that happens, again, we just have to recognize that that 1 is actually the a value. Our c value is going to be the value at the end, that negative 80. We're also going to have to recognize that our b value is this middle term, the negative 2. And we always include the signs with those values as well. So now our first step was to multiply our a and c values, the lead coefficient and the constant. So we have a times c, which in this case is 1 times negative 80. Now when you multiply 1 times negative 80, you get negative 80. So this is our product. Once you have that product, we're going to do factors. And if you need to use the cheat sheet that I gave you guys last week for the factors, you can use that cheat sheet. So if you look at this cheat sheet here, these are all my factors of 80. So 80 is made up of either 1 and 80, 2 and 40, 4 and 20, 5 and 16, and 8 and 10. Now once you get good with this idea, you won't have to list them all out. You could probably do some of it without writing every single factor out. But for our notes, I'm going to go ahead and write them all out. So now, I have all my factors. But all these are positive factors, right? And our number that we have up here is a negative. So I couldn't have all positive numbers, because when you multiply positives, you don't get a negative. So what determines our sign? Well, the sign in the middle, the b value sign, will always be the sign of the bigger number. Because remember, we're going to have to add these. And when we add them, in order to get a negative number, the bigger of the values would have to be the negative. So on here, this is telling us that all these bigger values should have a negative sign with them. Now, the other thing is our sign on this one, whatever our original value was, tells us if we have to keep the signs the same or if they should be different. Well, if we get a negative, only one of them is going to be negative, because if you had 2 negatives, you get a positive number when multiplying, right? So here, having a negative, one is going to be negative, the other one has to be positive. So they're going to be opposites. If we had a positive number here, then they'd all have to have the same sign. But you still have to look at that middle value to see what sign they would be. Because if that middle value was negative, then they'd both be negatives if this was a positive. All right, so again, you got to look at those two signs in order to identify what to have here. So now that we have the proper signs, we got to go through which one of these can add up to be that middle term. So we have a negative 2. Do any of those add up to negative 2? So the last two there, positive 8 and negative 10, if you were to add those, they give you negative 2. So now, those are the values that we're using to split that middle term. So everything else about this stays the same. We still have the x squared. We still have the negative 80. But that middle term is being split. So instead of negative 2, we're going to have a positive 8 and negative 10. The x value, though, will still be with both because they have to be like terms. So now we have a positive 8x and we have a negative 10x. So now that we have our 4 terms, now we go back to factoring by grouping. All right? So we're back to factoring by grouping. And normally I wouldn't rewrite this step, but for the purpose of our notes, I'm going to rewrite this one just so you can see that that was a separate step. So now that we have these 4 terms, we're going to go to factoring by grouping. And I'm going to write that over here. Factor by, oops. So again, from this point on, it's what we did earlier in the week. We're going to split this. So now we have our 2 factors and our two terms. So we have 2 binomials. Each of those binomials, we're going to factor out the GCF for each one. So for the first set, if I factor out, let's see, these, they don't have a common numerical value, except for 1. They do have a common x value. So you could either say I'm taking out 1x or just x. What's left over? Well, if you divide x out of both of these, divide x out of the first one, you have x. Divide x out of the second one, you just have 8. On this set, well, we have a negative for the first term. So we're going to take a negative out with our common factor. We have 10 and 80. So common factor there is 10. So we're factoring out negative 10. So we're dividing that off of both values. And again, you get x plus 8. Again, at this point, if you don't have the same thing in those parentheses, something's wrong. Go back, check your work. It might be a GCF. Maybe you only took out a common factor, but not the greatest common factor. Or, since we had to do this extra work first, you might want to go back and double check, were our factors correct for what we had and what we wanted to add up to? So again, things to double check. Now that we have that, again, parentheses are the same. So same as last week, or sorry, same as earlier the week. These two come together, give us x plus 8 as 1, because again, that's our common factor now. So it comes out as a GCF. The other two come together as the other factors. So x minus 10. And that's it. Again, that would be our final answer. Now, I'm going to do another one. All right? So I have a few more that I want to do with you guys. So let's go to the next problem. The next problem I have is 5y squared minus 11y minus 12. Yeah, this one slightly harder because our first value is not a leading coefficient of 1, but we have an a value to start off. So identify that a value. Here it's at positive 5. Our c value, again, is the negative 12. And our b value, here in the middle, is negative 11. So just like we did on the last one, you're doing a times c. So 5 times negative 12. 5 times negative 12 is going to give us what? 60. And it's going to be a negative 60, right? All right. Keep my color coding the same. That would have been red. All right. From there, we're doing factors of that. So we have lots of factors of 60. Again, if you want to use your cheat sheet, you can. We have 1 and 60. We have 2 and 30. We have 3 and 20. 4 and 15. 5 and 12. 6 and 10. Now, normally whenever I list my factors, I like to always list the smaller factor to one side, bigger factor to the other side. Because when we go through and determine the signs, it's much easier just to go down one side and put all negatives. All right. So on this one, again, we have the negative in the middle. So the bigger number has to be a negative. So all these should be negatives. Over here, we have negative 60. So only one of them should be negative. The other one has to be positive. So now, do any of these values add up to negative 11? So again, just go through, add them, see which one gives it to you. Which one gives you negative 11? 4 and negative 15. Yeah, so these two added together gives us negative 11. So those are the two that we are using to split the middle term. So we're taking 5y squared, dropping that down. We're taking negative 12, dropping that down. But then that value in the middle gets split. So we have a positive 6y and a negative 10. Oh, oops, sorry, I copied the wrong values there. Let me try that again. I looked at the wrong two values. Wrong two values. We had them right when I asked you guys. I just wrote the wrong thing. Sorry, the ones I circled are the positive 4 and the negative 15. So, and again, those two, if you add them together, give us negative 11y. So we now have our 4 terms. Again, I'm not going to rewrite it this time. I'm just going to go straight to my factor and my grouping. So I split it. So we have 2 terms on both sides. So we have 2 binomials. For each one of the binomials, I'm looking to take out a common factor. From the first set, the only thing that I can take out that's a common factor there is the y. What's left over? 5y plus 4. On the other side, I have a negative, so I'm going to take out the negative again. 15 and 12, what comes out of both of those? 3. So I'm going to take 3 out. So I have negative 3 coming out. Divide both those numbers by negative 3. And again, I'm left with 5y plus 4. Again, my parentheses are the same. So that's now my GCF. It comes out in front together. And the y and the negative 3 come together. And that is factoring a trinomial using factoring by grouping. Yeah. Almost the exact same thing as we did when we just did factoring by grouping. The extra steps came with splitting that middle term. That's the only thing that's changed. Everything else is the same. So there are a couple other examples that I want to do with you guys. So let's go to another example. Now, depending on how big you write and what you write with, I'm going to go on to a new sheet of paper, but that's because I write in markers and it bleeds through to the back. So if you have more room, you can keep going on the same sheet. All right, on this next one, now this is our third type of factoring we've done, right? We've done factoring GCF, factoring by grouping, and now factoring trinomials. But in all 3 types of factoring, you still have to do something first. You always have to check for what at the very beginning? GCF. So you always have to start with GCF. No matter what type of factoring it is, you should always look for a common factor. The first 2 that we did, I gave you ones that didn't have common factors. Does this one have a common factor? Yeah. So we need to check for that GCF. So always keep that in mind. Check for GCF first. All right. Now, on this one, what is our common factor that we can take out? Two. All right, so we're going to take out that common factor of 2. So take 2 out to the front. It leaves us with p squared plus 7p plus 12. Now again, this 2 we won't need again until the end. All right, so before I only dropped it down 1 line, but we have 2 lines of work to do before we need it again now for this type of factoring. So I'm going to drop it down a little further. All right, so I'm just going to draw my arrow. It'll be there for later, so I don't forget about it. And I have to identify my A and C values. Now, originally in this problem, my A value was 2. But now I'm only looking at my current place here. I've already taken out the 2. The 2's out in front. It's not part of this trinomial anymore. So what's my A value now? It's just 1. So again, I'm using that new A value there. And what's my new C value as well?
12.
The 12. So that's my C value. My B, there in the middle, is a positive 7. So just like before, we're taking A times C. 1 times 12. Well, 1 times 12 gives us 12. We need factors of 12 that add to the middle. Now, there's only a couple factors for 12. There's either 1 and 12, there's 2 and 6, and there's 3 and 4. So there's only a few factors. All right? So now, for those, we have, do we need any negative signs this time? Well, our middle sign is positive. Our number here is positive. So all these numbers are going to be positive. So do any of these add up to give us the middle value of 7? 4 and 3, yeah. So the 2 down there at the end, 4 and 3, add up to 7. So those give us the B value we need. So that's what we're using to split 7 into 2 separate terms. So we're going to rewrite this. And we have the P squared plus 3p plus 4p. Again, we still have the 12 as well in the end. And now it's factoring by grouping. So, split it. We have what's coming out of each of these. P. We have P plus 3. On this set, what's coming out of both of those? 4. And this time it's a positive 4. Again, I always like writing my sign there because if I didn't show this crossbar to keep it mathematically accurate, you should have that positive sign there. And again, you get P plus 3. So now, we have the same thing in parentheses. We can factor that out to the front. P plus 3. And the other two come together. P plus 4. The 2 that we had at the very beginning coming out, again, it's still there. And now this is our final answer. Now, there is a little bit of a shortcut that I want to point out to you guys. All right? And I haven't pointed it out yet. It comes in anytime we have a lead coefficient of 1. And it doesn't matter if you look at it when our original was 1 or when you have a problem like this after you take out a GCF. All right? If you look at the first problem we did, where we had the lead coefficient of 1, if you look at the final answer included x plus 8 and x minus 10. Did we see plus 8 and minus 10 anywhere earlier in this problem?
Yeah.
Yeah, where at?
The second.
Right there, because we got those when we did these factors. All right? When we have a lead coefficient of 1, the factors we get from doing this actually end up as part of our final answer. All right? If you look at the one we just did, our lead coefficient of 1 from this point, we did this work, we had 3 and 4. What ended up being in our final answer? 3 and 4. So it is possible to go from this step, when our lead coefficient is 1, straight to the final answer. Again, it only works when our lead coefficient is 1. If you look at the second one we did, where our lead coefficient wasn't 1, we had 4 and negative 15. Those were not the two values that we had for the final answer, right? In this case, we did have a 4, but you won't always even have one of them be the same, all right? So again, it only happens if our lead coefficient is 1. So it's one of those shortcuts. If you remember that there's that shortcut, you can use it, or you can just do it the same every single time, and you don't have to worry about remembering anything extra, all right? So there are a couple other ones that I want to do with you guys. There are 2 more. How are we doing on time? Yeah, I think we can do both of these. So 2 other examples here. So let's go to the 4th example that I have. So now this time, 6x squared minus 38x plus 60. Now, again, is there a GCF? Is there a GCF? So on this one, all these share a common 2. Just go ahead and go. I don't have the password now. So we have 2 can come out of every single one of those. I'm going to take the 2 out. Again, that value will end up dropping down to our final answer in the end. So I'm just going to draw an arrow so I don't forget about it. And then values that are left over here. This divided by 2 is 3. This divided by 2 is 19. This divided by 2 is 30. So this time, even after we took out the GCF, we don't have a lead coefficient of 1. So we can't use the shortcut here. All right? Again, you won't always be able to use that shortcut. So on this one, identify our A and C values. Our A value this time is that 3. Our C value is the 30. And also the B value in the middle is 19. So just like we did before, A times C. So we're doing 3 times 30. Now, at this point, if you don't want to write out all the values, that's fine. Again, you shouldn't have to write out every single value every time. If you can think of values as you go. All right, now, we know on this one, the sign in the middle is negative. We also know this one's positive. What's going to be true about our signs for all of our factors? Anybody know? So in order to get a negative in the middle, but a positive number when we were multiplying, would have to be true about all these numbers. You don't have to erase anything. I'm going to erase this just because I'm trying to keep the color scheme of my notes the same the whole way through, so that if you look back at the notes, it makes sense. So don't erase anything. I'm writing the same numbers over, just in blue. Sorry. No, it's not that the factors are 5. We have, again, if you look at the negative signs, where they are, this sign always tells us that the bigger value has to be a negative. So the fact that our B value is negative, the bigger value has to be negative. The fact that this is positive means that our values have to share the same sign. So what would that then mean for all of these values that I'm writing out? They would all be what? They'd all be negative. Because the middle value is negative, so that means all the bigger ones have to be negative. But in order to get a positive 90, You can't multiply a negative and a positive and get a positive number. So anytime you have a positive number here, you have to have the same sign. So if these are negative, that means these would also have to be negative. So all the values are negative. We need values that add up to negative 19. What value here adds up to negative 19? What values here add up to negative 19? Negative 9 and negative 10. If you add those together, you get negative 19. So, those are two we're using to split it. So we rewrite it. We still have our 3x squared. Still got that 30. But again, the middle is being split. So I have a negative 9 and a negative 10, both with the x. So they're both negative in the middle. Then we go to our factoring by grouping. Split them. Common factor. For these two, we have a 3 and an x that can come out, leaving us with x minus 3. Here we have a negative out in front, so again, it's going to be a negative coming out. 10 and 30 both have 10 as the common factor. So then we're left with x minus 3. The x minus 3 is the same, so it comes out as our GCF. And the other two come together. The x minus 10. The 2 from the beginning comes all the way down, and we have our final answer. All right. One last example. So the one thing that I'm going to add in this last example, again, we're going to have a GCF, just like we've had on the last two. However, this time, that first term is negative. So when we take out our GCF, what do we going to want to take out? We want to take out the negative with that GCF. So here we have a GCF of negative 4. It's going to come out. So divide this by negative 4, you're left with just x squared. Divide this by negative 4, you're left with positive 2x. Excuse me. Divide this by negative 4, we get negative 48. Sorry. So again, that 4 will come all the way down. We'll worry about it later. And you treat everything the same. Sorry. All right. So again, we have our trinomial. Our a value here is 1. So if you want to use a shortcut, you could. All right. Our c value is at negative 48. And our b value is the positive 2. So 1 times negative 48 is 48. And now we need factors of 48 that adds to the middle term. Now notice, we have a positive middle term. So that means our biggest number is going to be positive. We have a negative 48. So one of the values has to be a negative. So the bigger number this time is going to be positive. The smaller value will be our negative. So as we go through, again, if you want to list them all out, you can keep listing them all out. But we could probably think of some numbers that would give us 48. And if you can think of numbers that give you 48, but add together to give you 2, or whose difference will be 2. All right. So 8 and 6, that's it. Now, which one should be negative though? In this case though, we want the 6 to be the negative, because on here, the middle number being positive, that means that the bigger of the two has to be the positive. So now, there's like 3 other factors for this one. But if you can think of them fast, you don't have to list them all out every single time. Or if you're using your little cheat sheet, again, you can go straight from your cheat sheet and look at, all right, which 2 are they that you need? And that's fine. All right, again, for the purpose of notes, I've been writing them out every time. But now, these 2 are the 2 that work. They add up to a positive 2. So that's what we're going to have to use to split the middle term. Now, like I said, we have a lead coefficient of 1. So we could use that shortcut. We could actually go straight to our final answer right now. We already know that the number out in front is going to be negative 4, because we had to take that out at the beginning. And then for our 2 factors, we are going to end up with x minus 6 and x plus 8. Again, I could go straight to that final answer because we have a lead coefficient of 1. Again, those 2 will have to be the 2 values in my final answer. Now, I'm going to show the rest of the work as well, just so you see that that shortcut works. But again, I'm showing you that we could have went straight there. Now, if I rewrite this, again, I'm using that to split the middle term. I would have had x squared minus 6x plus 8x minus 48. I would have done my factoring by grouping, split it into 2 binomials. I would take out the x from each one of these. So take out the x, I'm left with x minus 6. That was my GCF. The GCF for this set is a positive number this time. So plus, I'm taking out an 8. And then I'm left with x minus 6. The x minus 6 is the same. It comes out in front together. The other 2 come together as my other binomial. Same answer. Again, that shortcut only works though if the lead coefficient, the a value, is 1. All right. Now, we're done. You don't have to write anything else down. I do want to show one other thing real fast. And that's just the idea of when you take these values, it actually does not matter what order you write them in. So I'm going to go back for a second to example, what was this? Example 2. So let me throw example 2 back up here real fast. When we took these 2 values, we put them in the order of 4 and then negative 15. The order doesn't matter. Some teachers will say, oh, the 15 should have gone with the 5, the 4 should have gone with the 12, and then you factor. It doesn't matter. There does not have to be any common factors there. Just to show you, again, if you were to have switched them up, you get the same exact answer. The only difference is the answer in the end. The 2 factors end up switching places. But again, the order in which you write your factors doesn't matter. So again, I know some teachers focus on that. There's no reason to worry about which one comes first or which one comes second. You get the same answer. All right. You still have to take out a GCF. It might be a different GCF, but you still get the same answer in the end. All right. So I just wanted to show that. All right. Any questions about what we did today? It wasn't much harder than what we did yesterday, right? It was just a couple extra steps. So tomorrow we'll practice this. I'll check off the other assignments that I didn't get a chance to today. Thank you guys for letting me do it in this order so I could get this recording done so I could post it.